Welcome to This Explainer. Today, we're diving straight into what is finally forcing the massive and, let's be honest, notoriously stubborn construction industry to go green. We'll be looking at the hard data, the emerging tech, and the policies that are literally changing how we build the world around us.
Right now, we are only at a 58% implementation rate for circular building strategies across the sector. It's a start, sure, but it's certainly not enough given the stakes. But here is what is pushing us toward 100%.
So you see this 42% gap? To hit our global climate goals, like limiting temperature rise to less than 2 degrees Celsius, we absolutely must close it. It's basically a ticking clock against our old, entrenched linear ways of doing things. We simply cannot afford to keep building the way we used to.
Because the reality is traditional construction is drastically failing the Paris Agreement. I mean, the sector eats up to 45% of global resources. Plus, it generates over a third of all greenhouse gas emissions and waste in Europe. Millions of tons of perfectly good materials are dumped in landfills simply because a building goes out of style or doesn't fit a specific need anymore, what they call functional obsolescence. If we just keep doing business as usual, emissions from materials management are going to balloon to an unbelievable 50 gigatons by 2060.
Okay, so let's unpack this huge paradigm shift. Our built environment has to move away from the old linear take, make, and waste model. We need a circular one, where materials stay in continuous, high-value use. Instead of just extracting raw materials, building something, and eventually tearing it down, we need to regenerate, reuse, and recycle. The goal here is to preserve a building's embodied carbon, which is all the greenhouse gas emissions already spent making and moving its original parts, for as long as technically possible.
We're going to break this down by looking at 3 main accelerators: technological, political, and financial drivers.
Let's jump into Section 1, technological drivers. Think of this as the digital dashboard and data running the whole transition.
To fix the traceability problems we've had in the past, we start with life cycle assessment, or LCA. This is an essential tool that looks at a material's true environmental impact from the second it's manufactured through its everyday use all the way to how it's disposed of. It totally takes the guesswork out, giving architects the hard, undeniable data they need to pick low-impact, durable materials right from the get-go.
And that brings us to Building Information Modeling, or BIM. BIM uses 3D models and material passports to perfectly track every single component. You can think of these passports as digital ID cards for every beam, brick, and window. They record exactly what a material is and how it's been used. So 50 years from now, a deconstruction crew will know exactly how to pull that building apart and save the pieces without wrecking them. Plus, standardizing these secondary materials is a massive tech driver. By standardizing dimensions and material types, we make sure reclaimed resources are actually trusted by future builders. It creates exchangeability, so a component doesn't just become trash because it's slightly the wrong size. It's honestly a lot like standardizing Lego bricks, making everything a highly credible, usable resource for the next project.
Moving on to Section 2, political drivers. These are the mandates and targets forcing the industry's hand.
You know, tech is great, but it really isn't enough without solid policy backing it up. We've seen some incredibly powerful interventions recently, like the 2008 EU Waste Framework Directive, which targeted a massive 70% reduction in construction waste. And as we move through the 2020 Nationally Determined Contributions revisions and look ahead to 2025, we're seeing vital emissions targets that literally mandate a shift to low-carbon materials and nature-based solutions.
Governments are seriously stepping up here. They're actively incentivizing eco-designs and mandating green public procurement. This means government buildings have to invest in low-emissions materials. Think about it. When a city commits to using reclaimed materials for its own public works, like, say, using 80% waste flooring in a new town hall, they create this massive, immediate market demand that forces the entire supply chain to adapt and fast.
All right, on to Section 3, financial drivers. This is all about the economic carrots and sticks.
At the end of the day, without the right economic incentives, the market just won't shift. It really requires a classic carrot and stick approach. We're talking about contrasting heavy green taxes on virgin, brand new materials against very appealing tax rewards and reduced VAT for secondary, reused materials. By making it incredibly expensive to extract raw materials or dump things in a landfill, and actually subsidizing the reuse of components, the sustainable choice suddenly becomes the profitable choice.
Now, circular projects often require higher upfront investments. You have R&D costs for setting up reverse logistics, which is basically figuring out how to transport materials backward from a demolition site to a manufacturer. Or you have to pay skilled labor to carefully take a building apart instead of just wrecking balling it. Because of those upfront costs, financial incentives are absolutely vital to motivate long-term collaboration across the whole supply chain. They push developers away from those quick, short-term returns of traditional building.
And of course, financial viability has to balance with environmental benefits. A big part of this is optimizing local sourcing to keep transportation emissions low. This is the whole idea behind urban mining. If you harvest reclaimed doors from an old building right down the street, you preserve that embodied energy. But if you have to ship those same doors across borders, the transportation emissions totally erase your environmental gains. Finding that sweet spot, sourcing within optimal boundaries, is key.
Section 4. Reaching 100% circularity.
So, how do we hit that goal? Well, by blending high-tech data, strict policies, and smart money, we can actually build resilient, circular cities that mitigate climate change and give us vibrant, healthy spaces to live in. We can transition away from linear cities that are just drowning in municipal waste and move toward environments that lock in permanent energy savings and actively regenerate our existing resources.
As we wrap up this explainer, I want to leave you with a thought, and honestly a bit of a challenge. Take a look around. Just how circular is the building you're sitting in right now? And what exactly will it take to transform it? Look at the walls, the flooring, the layout. How much of it was actually designed to be adapted, converted, or eventually disassembled? A circular future is absolutely possible, but it starts with us questioning the built environment we are sitting in today.